In this video, we'll take overlap and add method. Overlap and add method is another method to perform a linear convolution between two sequences where one sequence is of finite length and another sequence is of infinite length. Here infinite length in the sense it will be having long sequence. Now let's see the procedure to perform linear convolution between two sequences using overlap and add method. So let x of n is input sequence and we'll assume that the length of this is ls. ls is long sequence, that is it is having more number of samples. Similarly, let h of n is impulse response of the system. We'll assume that the length of h of n is say m. So in overlap and add method, the input sequence x of n is divided into different small blocks. Divide x of n into smaller blocks. Each block consists of L number of input samples and m minus 1 number of zeros. That is, length of each small block is n is equal to L plus m minus 1. So as I said, x of n will be divided into smaller blocks. The length of each block is n, that is it consists of L number of samples and m minus 1 number of zeros. The next step is, if n is not given, then compute n using the relation n is equal to 2 power m, where m is length of impulse response. Each small blocks are represented as x1 of n. So as I said, x1 of n will be equal to L samples of x of n. I can call it as x of 0, x of 1, x of 2 and so on, x of L minus 1. That is L samples of x of n followed by m minus 1 zeros. So here I can call it as L samples of x of n followed by m minus 1 zeros. So length of each x1 of n or each block is n. That is, here I can write length is equal to n. Similarly, x2 of n, which is equal to next L samples of x of n. That is, here we have taken L samples of x of n. The remaining next L samples of x of n is to be considered in x2 of n. That is, it consists of, here it is ended with L minus 1. It begins with next sample, that is x of L. Next sample is x of L plus 1 and so on. The last sample will be x of 2L minus 1. And here also it is followed by or appended with m minus 1 zeros. So here this is nothing but again L samples of x of n. I can say L new samples of x of n. Similarly, this will be m minus 1 zeros. This process will be continued until all the samples of x of n is considered. Then the next step is length of h of n, where h of n is impulse response. Length of h of n should be made equal to n by L minus 1 number of zeros. Then perform circular convolution, that is, here we supposed to perform the circular convolution between each small blocks with h of n, that is x1 of n, circular convolution with h of n. I will call it as y1 of n. Similarly, we supposed to perform y2 of n, which is nothing but circular convolution between second sub block, that is x2 of n, with h of n, and so on. This process is to be continued until the convolution between h of n and all the blocks is completed. Here we can see that after performing the circular convolution, the resultant sequence, that is y1 of n or y2 of n, will be consists of n number of samples. So in next step, we supposed to consider, that is, the last m minus 1 samples of y1 of n is to be overlapped and added with first m minus 1 samples of y2 of n. Similarly, the last m minus 1 samples of y2 of n is to be overlapped and added with first m minus 1 samples of y3 of n, and so on. That is, I can write similarly last m minus 1 samples of y2 of n is to be overlapped and added with first m minus 1 samples of y3 of n, and so on. So this process is to be continued until all the resultant y of n is considered. Thus, we get final sequence y of n. Now I will consider one simple example. I will calculate the linear convolution between two sequences using overlap and add method, so that one can easily understand these all steps. Using overlap and add method, compute the output of an FIR filter with impulse response h of n and input x of n. Use only 8-point circular convolution in your approach. We'll try to perform the convolution between x of n and h of n. That is, it is given by y of n is equal to x of n convolution between h of n. So here I will explain all the steps that how to perform the linear convolution between two sequences using overlap and add method. Here we can see that x of n sequence is given, that is x of n is equal to, as I said here, length of x of n is say ls. So here length is equal to ls, which is equal to, here it is having 1 2 3 4 5 6 7 8 9 10 11 12 samples, that is ls is equal to 12. Similarly, we have h of n. It consists of 3 samples, 1 minus 2 and 3. The length is here, that is m is equal to 3. So ls and m we have found from the given. Here I have said that if n is not given, then compute n using the relation n equal to 2 power m. But in our example, here n value is given, that is, this is nothing but n. Use only 8-point circular convolution. So n is equal to 8, that is given in the problem. Now we'll make use of this relation, that is n is equal to l plus m minus 1. N is equal to L plus M minus 1. So here N value is known, M value is known, but L is unknown. So from this I can extract L. L is equal to N minus M plus 1, which is equal to N value is 8 minus 3 plus 1 is equal to 6. Therefore L is equal to. So now divide x of n into smaller blocks. We'll divide x of n into x1 of n and x2 of n and so on. So now we'll divide this x of n. I will write the first block. X1 of n is equal to, so as I said here, it consists of L samples of x of n. Here L value is 6. So consider first 6 samples of x of n. That is 1, 2, 3, 4, 5, 6. So consider first 6 samples of x of n, and I'll write here 2, minus 2, 8, minus 2, minus 2 and minus 3, followed by m minus 1 zeros. So here m value is 3, 3 minus 1 is 2. So we are supposed to add 2 zeros. So here we can see that length of x1 of n is 8. Similarly, x2 of n is equal to the next 6 samples of x of n, that is 1, 2, 3, 4, 5, 6. So I will write here minus 2, 1, minus 1, 9, 1, 3, followed by 2 zeros. So now here we can see that all the samples of x of n is over. So we are supposed to stop dividing of the block into small blocks. So the next step is length of h of n should be made equal to n by padding l minus 1 number of zeros. So here h of n is 1, minus 2 and 3. It consists of only 3 samples. We are supposed to make it n. Therefore, the new h of n is h of n is equal to 1 minus 2 minus 3. Its length should be made equal to n, that is made equal to 8 by padding l minus 1 zeros. So here l is 6, l minus 1 means we are supposed to add 5 zeros. So this is new h of n. Now we are supposed to perform the circular convolution between x1 of n and h of n, then x2 of n and h of n. Now perform circular convolution between small blocks with h of n. That is, I can write y1 of n is equal to x1 of n. So here n is equal to 8, h of n. So therefore, circular convolution is calculated using matrix method. The first column is output column, y1 of 0, y1 of 1, y1 of 2, y1 of 3, y1 of 4, y1 of 5, y1 of 6, y1 of 7. So this is the column matrix. So now write the samples of x1 of n vertically. So x1 of n is 2 minus 2, 8. Minus 2 minus 2 minus 3. Next two samples are 0, 0. Now similarly, write the same sequence x1 of n in reverse order in the first row. That is, we supposed to start from 0, 0, 0, minus 3, minus 2, minus 2, 8, minus 2. That is 0, 0, minus 3, minus 2, 8, minus 2. So this will be square matrix. So this is 8 cross 1. This will be 8 cross 8 matrix. So now write this is 2 here. This 0 should be written here. This 0 should be written here. Diagonally we are supposed to represent the values. This is minus 3. Write this minus 2 here. This minus 2 here. This 8 supposed to be represented here. This process is to be continued. This is minus 2. Here it is 2. Here it is 0. Here it is 0. Here it is minus 3. Here it is minus 2. Here it is minus 2. This is 8. Minus 2. 2. This is 0. This is 0. This is minus 3 and this is minus 2. Next, this minus 2 is to be written here. This is 8. Minus 2. 2. 0. 0. Minus 3. Next, this is minus 2. Minus 2. 8. Minus 2. 2. 0. 0. This is minus 3. Minus 2. Minus 2. 8. Minus 2. 2. 0. 0. Minus 3. Minus 2. Minus 2. 8. Minus 2. 2. So now here we'll write h of n sequence vertically. So h of n is 1, minus 2, 3, remaining all are zeros. That is 1, minus 2, 3, 0, 0, 0, 0 and 0. Now perform the matrix multiplication between these two matrices. So size of this one is 8 cross 1. So 2 into 1 is 2. This is 0. This into this is 0. Minus 3 into 0 is 0. So here rest all values will be 0. Next we'll multiply second row with column, that is minus 2 into 1 is minus 2. Then 2 into minus 2 is minus 4. 0 into 3 is 0. 0 into 0. Rest all values are 8 into 1 is 8. Minus 2 into minus 2 is 4. 2 into 3 is plus 6. Rest all values will be 0. Next minus 2 into 1, minus 2, 8 into 2, minus 16, minus 2 into 3, minus 6. Rest all values will be 0. Next minus 2 into 1, minus 2, minus 2 into minus 2 is plus 4, minus 2 plus 4 plus 24, rest all values 0. So now simplifying this, I'll get y of n as this is 2, this is minus 6, 18, minus 24, 26, minus 5, this is 0, minus 9. So this is y1 of n sequence. Similarly, now calculate y2 of n. y2 of n is equal to x2 of n convolution with h of n. Therefore, I can write here as y2 of 0, y2 of 1, 2, 3, 4, 5, 6, 7. So now write x2 of n sequence vertically. x2 of n is minus 2, 1, minus 9. 9, 1, 3, 0, 0. Now write the same sequence x2 of n in reverse order in first row, that is 0, 0, 3, 1, 0, 0, 3, 1. Then we have 9, minus 1, 1. 9, minus 1, 1. Now write this 2 here, 0 here, 0 here diagonally. Now you write 1 here, minus 2, 0, 0, 3, 1, 9, minus 1, 1, minus 2, 0, 0, 3, 1, 9, minus 1, 1, minus 2, 0, 0, 3, 1, 9, minus 1, 1, minus 2, 0, 0, 3, 1, 9, minus 1, 1, minus 2, 0, 0, 3, 1, 9, minus 1, 1, minus 2. So now here we'll write the H of n matrix, that is 1, minus 2, 3, all are zeros. 1, minus 2, 3. So now we'll perform the matrix multiplication. Minus 2 into 1 is minus 2. This is 0. This is 0. Rest all are zeros. 1 into 1 is 1. Minus 2 into minus 2 is plus 4. So rest all are zeros. Minus 1 into 1 is minus 1. Minus 2. Minus 2 into 3 is minus 6. Rest all are zeros. 9 into 1 is 9. 1 in minus 1 into minus 2 is plus 2. Then 1 into 3 is plus 1 into 1 is 1. 9 into minus 2 is minus 18. Minus 1 into 3 is minus 3. 3 into 1 is 3. 1 into minus 2 minus 2. 9 into 3 is plus 27. Then 0 into 1 is 0, 3 into minus 2 is minus 6, 1 into 3 is plus 3, then 0 into 1 is 0, 0 into minus 2 is 0, 3 into 3 is 9. So I can write minus 2, 5, minus 9, 14, minus 20, 28, minus 3 and 9. So now I will write here y1 of n sequence minus 6, 18, minus 24, 26, minus 5, 0, minus 9. Similarly, I will write y2 of n sequence, which is minus 2, 5, minus 9, 14, minus 20, 28, minus 3 and 9. The last m minus 1 samples of y1 of n is to be overlapped and added with first m minus 1 samples of y2 of n. So here last m minus 1 samples, m value is 3, so last two samples. These two samples are overlapped and added with first m minus 1 samples of y2 of n. That is, now I will write the final output sequence y of n is equal to, we supposed to write the remaining content of y1 of n as it is, that is 2, minus 6, 18, minus 24, 26, minus 5. Now this 0 should be added with minus 2, so it results minus 2. This minus 9 should be added with 5, it gives minus 4. Now remaining sample should be written as it is, that is minus 9, 14, minus 20, 28, minus 3 and 9. So this is the output sequence y of n. Thank you for watching.